elementary row operation as the row 1 can now be replaced as row 1 minus 1/4 of rows of 2. For row 3 can now be replaced as element in row 3 plus element in row 2. So this will be our next simplex W as, since again we have to remain the elements in row 2, so just simply rewrite on the next simplex W. Then, for the elements in row 1, this is now row 1 minus 1/4 of row 2. So this is just simply 1 minus 0. So the answer is still 1. 1/4 minus 1/4. So this is now 0. 0 minus 1 over 32. So the answer is negative 1 over 32. 3/8 minus of negative. So this is now positive. So 3/8 plus 1 over 8. So that will be 4 over 8 or simply 1/2. Negative 1/8 minus 3 over 8. So the answer is negative 1/2. 0 minus 0. The answer is 0. 95 over 4 minus 35 over 4. So this is 60 over 4 or just simply 15. For the elements in row 3 can now be replaced by row 3 plus row 2. So this is simply 0 plus 0, the answer is 0. Negative 1 plus 1, the answer is 0. 0 plus 1, 8. So the answer is 1, 8. 3 halves minus 1/2, the answer is 1. 3 halves plus 3 halves is 6 over 2 or simply 3. 1 plus 0, the answer is 1. 195 plus 35, the answer is 230. Now this time, since there will be no negative values in the last row, then they are now said to be as in optimal column. But then again, with respect to the simplex method alone, this time for the duality, the value for the variable u as our slack variable and the v slack variable are now equal to the given variable in our primal problem, which is x of 1 and x of 2. So then the u is our x of 1 and v is our x of 2. Now how can we find the values of these unknowns? Since they are now in optimal column, then we can find the value of variable y of 1 as equal to 15, because as from the 1 connect to the constant column, this is now equal to 15. For y's of 2, from the coefficient 1 connect into constant column, so the answer is 35. But for y's of 3, since there's no one value element here, therefore y's of 3 is equal to 0. Now for the slack variable u and v, as we mentioned that u is our x of 1, then the value of u here, which is our x of 1, is equal to 1. This is the value of the x of 1. And for the v, as for our x of 2, this is now equal to 3. For the objective function, connect the coefficient of it as 1 into the constant column, and this is now equal to 230. As for our dual problem, we can have now a decision that for the primal solution, we have the x of 1 and x of 2 as equal to 1 and 3 respectively, because these are the values for u, slack variable, and v, slack variable respectively. And for our dual solution, which the variables are y's of 1, y's of 2, y's of 3, then the values are 15 for y's of 1, 35 for y's of 2, and 0 for y's of 3. And this is our decision now that in order to have a minimum cost of z, which is 230, the value for x of 1 and x of 2 should be equal to 1 and 3 respectively.